Okay, so let's work this example of the free fall problem. And in this problem, we have a man standing on the edge of a cliff, and he throws a ball straight upward with an initial velocity of 15 meters per second. Okay? And we know that when a ball is released, when a ball is kind of not held by anything, it's in free fall, even if it's moving upward. So it's going to have a y acceleration of g, 9.8 meters per second squared, downward, thus the minus sign. So we've already kind of got the problem sort of set up here. And in the first part of the question, we're asked to find how long it takes the ball to make it to the top of its flight. Okay? So our ball is thrown. Here's the guy on the edge of his on the cliff. And he throws the ball straight upward, and it reaches the top of its flight. Now, when the ball is at the top of its flight here, okay, we're interested in knowing what its y velocity is. And when a ball is at the top of its flight, it's basically moving upward, and it comes to a stop before falling back down. So its y velocity here at the top of its flight is 0. The ball has come to a stop. Okay? And in part A, that's our information right there. We want to know the time it takes to reach the top of its flight. So when we go through our list of equations, we want to find the equation that works best for this set of variables, time, and this set of variables here. Now, remember, all our equations so far are in terms of x, but they work just as well if you substitute y in there, okay? So we're just going to, these equations are going to look slightly different because they're going to have y in there. So the best equation, going through that list of equations for this situation, is this one. Vy final equals Vy initial plus y acceleration times time. Or, you know, as we had it listed all previously, we had it as delta t. But t is basically, it's the same thing. So we can now plug this information in here. Vy final is 0. Vy initial is 15. Y acceleration is negative 9.8 times time. So this becomes an algebra problem. We solve that. We find that the time it takes to get to the top of its flight is 1.53 seconds. Okay? So that's the solution to that part of the problem. Now, we now want to know what is the maximum height. In part B, what is the maximum height of the ball above the cliff? So let's go ahead and erase this stuff here. And so in part B, we want to know the maximum height. So we now want to know the height, or basically y final minus y initial. Okay? So here's our final y height. Here's our initial y height. So that's delta y. So going through our list of equations, the one that works best is this one. And remember, this is all in terms of x, the way we've had it so far, but it works just as well if you just substitute y in there. Plus 2 times the y acceleration times delta y. Okay? So we can plug these numbers in here. Y final is 0. Y initial is 15. We have to square that. Plus 2 times the y acceleration, negative 9.8, times our delta y. Okay? So a little bit of algebra here. Square 15, bring it to the other side, then divide both sides by 2, and divide both sides by negative 9.8, and you find that delta y, which is in fact the height above the man and above the edge of the cliff, that height is 11.5 meters. Okay? So that was part B. Now in part C, we're asked how fast is it moving when it gets back down to the man here? Okay, how fast is it falling downward? So a slightly different moment in time for part C. So let's do some erasing here. Okay, part C now. Okay. It's no longer the case that our final velocity is 0. Okay. So here is, we want to know what the velocity is down there. Now, so we still have these exact same values still apply, but what else do we know about the motion of this ball? Well, we know that its final height is the same as the initial height. Okay? So our displacement, then, of the ball, delta y, which is y final minus y initial, is 0, because the ball is returned back to its initial height. Okay? And we're asked to now find Vy final. Okay, going through our list of equations, the best equation that fits this set of variables is still this equation here. Okay. And substituting values in here, Vy final squared equals this, Vy initial, which is 15 squared, plus 2 times negative 9.8 times delta y. But delta y is 0. Okay? So that term is 0. So what we find is Vy final, after taking the square root of this here, it's not just positive 15. You get 2 solutions. When you take the square root of 15 squared, you have 2 solutions. One is plus, one is minus 15 meters per second. Now, you can't have 2 solutions to this problem. There's only one solution. So we want to pick the solution that makes the most sense. The only one that makes physical sense is the negative solution. The ball's traveling downward, or the rock, whatever we're talking about here. So that's minus 15 meters per second is our solution. So the ball is traveling downward when it gets back to the man at exactly the same speed as it was thrown upward. Okay? Now we know that's not the case in our everyday lives. The reason for that is air resistance. But if there is no air resistance, you throw something upward, it's going to be traveling at exactly the same speed when it gets back down to your hand. Okay?